Good morning, Youth Build. Good morning, world that is seeing this video. I am Neil Solano, and I will be your tutorial teacher, instructor, / professor for the day. What are we studying today? Today we are doing equation basics, right? This is priority number 1 in all of the math GED, you guys. If there's ever a time to look at a video from beginning to end, it's this one. If there's ever a time to put up with my crazy voice and methods of teaching, it is this one. You guys need to master this 1000%. So let's dive right into it. What are equations? Well, let's go back very quick. What's this right here? What's this right here? Equations. Does that sound familiar? Yes, you guessed it. Equals. Whenever you see an equal sign, that means an equation. It means 2 equals 2. That's a true statement right there, you guys. 2 does not equal 1 or 3 or 4 or any other number. It equals 2. Same way as 3 equals 3, 4 equals 4 and whatnot. That is an equation. Something with an equal sign. That's the basics right there, what I just showed you. Let's say, let me give you this problem. 2 plus 6 equals 2 times 4. This is also a valid equation. As you guys can see, 2 plus 6 creates an 8. 2 times 4 creates an 8. Making this a valid statement, making this a valid equation. 8 equals 8. That is true. Obviously, this is what we would like in math, is for them to give us all the numbers and whatnot. But what happens, you guys, when you're missing a number and you're given a variable instead? Like, let's say instead of this 6, you're given an x, right? Or a or b, whatever, any variable, and it says find the missing number. What is x? Well, you solve it. Now this is going to be more in the next video of the more advanced equations, even though I'm sure you guys can already guess what it is, right? Or come up with a way of finding that answer, finding the x value mathematically wise, not common sense wise. But we're going to touch that later on in the next video. Today I want to show you the methods of how to find these basic operations, basic numbers, the missing number that you need to find. So here we have a standard basic equation, right? 4 plus a number equals 11. Now, using common sense, you guys could already see that x would be 7, right? You already know that 4 plus 7 would equal 11. But there is a way of finding this mathematically. And this is what you guys got to do. This symbol right here, addition, what does it do? It separates these two terms, right? This portion, this side of the equal sign, let's say, is a binomial. You guys already learned that. You guys already know this. And on this side, all we have is a monomial, right? So it's a binomial because this is being separated from this x by that plus, right? That is key. You have to identify what you're dealing with, right? Because if this 4 is not attached with this x, I'm going to use an operation to leave x by itself. That's what we're trying to do here, you guys. What we try to do mathematically to solve equations is always have the same stuff on one side and the other stuff on the other side of the equal sign. This is what I mean by that, alright? This is a variable. And let me use a different color. This is a number and this is a number. Alright? This 4 is far away from this 11 right here. It is really far away. You know why? Because this equal sign is somewhat dividing two worlds, all right? You kind of want to think of an equal sign dividing two separate neighborhoods, two different universes, two different whatever it is that you could think of. It is dividing two separate things. Not dividing as in division. I just mean like it's separating two separate worlds. As in this side is Earth, right? And on this side is something similar, but not really, is Mars, let's say, right? On this side of the equal sign, we have Earthlings. On this side, we have Martians, right? That is a nice little method of remembering what I'm about to say next, right? Because what we want is all Earthlings on one side and all Martians on the other. And the thing is, right now, we have an Earthling here, or sorry, we have a Martian there, and we have a Martian here, and we have an Earthling there, right? We need the Earthlings, the Martians to be there together, and the Earthlings to be together. So that's what we're trying to do. What we're trying to do is get this 4 over on this side in its original world. It's Mars planet, right? And this Earthling over here is perfectly fine where it's at. It's perfectly fine, but whatever. We don't deal with that just yet. So how do I move this 4 over to the other side? That's the key that you're always asking. That's always what you're asking yourself when it comes down to equations. You gotta ask yourself, what am I gonna do? What am I gonna use to move that term to its designated area? Well, there's a reason why I mentioned the whole separation, right? It's a binomial, right? One term separated from the other. The reason why is because this 4 is alone. Right, it's not attached with this x, which means you use the opposite of its symbol. In this case, it's a plus, even though it's not visibly there, right? Use the opposite of its symbol so that it can cancel out from here in the Earthlings, in the Earth side, right? You want to cross it out, and then it'll, whatever you do to one side, it'll go to the other. So whatever you do there, it will go over here, right? So what do I mean by that? If this is a 4, positive 4, what's the opposite of positive? Negative. You minus 4 from that positive 4 so that it cancels out. Basically creates a 0. Am I right? And then it gets minused from its like term on the opposite side. So 11 minus 4, what is it? It's 7. So what does all this become? Well, what it becomes is, if you simplify down here, you rewrite the problem, you have x equals 7, which is what the end goal always is, am I right? You have x equals something. X, we found x, right? X equals 7. That is how you find these type of answers, by using the opposite of the number that you're moving, or the variable that you're moving's symbol. Now, let's use another problem so that you guys don't get confused. Let's say it was this. Negative 2 plus x equals 3. Right? It's the same thing. You guys are already experts on indicating binomials, right? Monomials. You guys already know polynomials well. You guys should. If not, go back to my videos. Right? And you see that this side has 2 terms, right? And because it's separating, they're not attached, basically. All you're going to do is use the term symbols to move to the side that you need to move. So what are we going to move here? Are we going to move this positive x? Are we going to do the opposite of it and cancel it out here so it goes over there? Or are we going to add 2 so it cancels out here and gets thrown over there? Well, this is why I explained to you the whole Martian and Earthling thing, is because what needs to go where? On this side we have one world, on this other side we have another, right? So you have to have all things to one side that that are like terms, basically, right? So it makes no sense, having that in your head, to move this x over here. Why? Because all you'll have is a number with with an x, basically, and that makes no sense. That's not what we're trying to do. What, a Earthling with a Martian? No, 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 no. We do not want that, right? It makes sense to move this 2 by doing its opposite, remember? Plus 2. So it cancels out and gets thrown over here. Now you have x equals 5. That is how you solve equations. I guess the hardest part is realizing what needs to be moved where, and then making a decision on how you're gonna move it to the opposite side. Now I know you guys are saying, oh, that's easy, right? That doesn't seem that hard. But a lot of people make the mistake of, subtracting 2 and canceling out and subtracting 2. That gives you a different answer. You always got to do the opposite of its symbol, all right? That was a case with subtraction. The other one was with a positive, right? Let's go and see something else right now. Let's put up a 3x, all right, equals 24. All right, what do we have here, you guys? What is this? I don't see no binomial. This is a monomial. This is a monomial. How do I solve this? How do I solve for x? Well, you guys, it's easy, all right? What does this actually indicate? All right, before the problems that we showed you, this 2 was detached from this x because of this operation, right? This one, they're together. What does that imply? What does that mean when they're together? You guys should remember this. It pretty much means multiplication, right? Nothing too complicated there. It means 3x means 3 times a number, right? 3 times x, 3 times a number. And this question is asking, what is that number? What is x equals? So that's what I gotta find. What I want to do is leave x by itself so that I have a final solution where it says x equals something, right? How do you leave x by itself? How do you get this little Martian, which is the number, and throw it over there with its other Martian buddy? Well, you always do the opposite. Now, this is the first trick. I just said do the opposite, alright? Oh, this is a positive 3. I'm just going to minus 3 and it cancels out. Yeah, no, that's not right. In this case, whenever you have a number attached with a variable, which basically just means multiplication, whenever you have a multiplication problem on one side of the equal sign, what you got to do is the opposite. Not in terms of the symbol, but in terms of the operation. So if this means 3 times x, what's the opposite of multiplication? Division. So I'm just going to divide that 3 so it cancels out. And then it gets thrown over here under its other like term. Because the 3's canceled out there, and all this is a standard division problem, what's 24 divided by 3? It's 8. So when you do that, I shouldn't be erasing this. What am I doing? When you do that, what you end up getting is x equals 8. That's how you solve for x whenever you have them attached. The end goal is to have all things on one side and all other things on the other side, right? So all I was trying to do here was eliminate this 3 so that x was by itself, so it would look like this. Pretty cool, huh? Pretty cool. That was multiplication. What happens if you're given a problem that looks like this? X divided by 2 equals 17. What does this imply? Well, you already know that fractions means division, right? So all it is a division problem. I have number right there, and it's being separated from this other number. It's girlfriend. It's Martian girlfriend, and it wants to go over there. How do you get that 2 over there so that we have x equals the final? That was supposed to be a question mark, my bad. So how do you leave it x by itself? How do you get that 2 over there so x is by itself and x equals a number? Well, do the tricks that I just showed you. Do the opposite. This is division. What is the opposite of division? Multiplication. What do you multiply though, Neil? That's probably what you're asking yourself. What do you multiply? What you multiply is the bottom number, the denominator. If that's a 2, you're just going to multiply it by a 2. Cancels out. X is finally by itself. X equals, right? But remember what I said, what you do on one side, you do the other, right? So this times 2 now gets thrown over here. 17 times 2, right? So, like I said, this x is by itself, comes down over here. So x equals the solution of that problem, which is a standard multiplication, which is 34. So x equals 34. Another problem would be this. This is sticking with the division problem, all right? 120 over x equals 24, right? What do you do here? Now, if you see before, we had the x at the top and the number at the bottom. So all you did was multiply by the bottom number, right? This is the letter at the bottom and the number at the top. Oops. So what do you do there? Same thing, you guys. Literally the same thing. You multiply by the x, cancels out, and it gets thrown over here. 24 times x, which looks like how? The same as 24x, right? So when you rewrite your whole problem now, you have this. Actually, I think I need space. So let me make a little bit of space here, you guys. So the new problem now looks like this. 120 equals 24x. Now what do? Well, the problem looks similar, doesn't it? Looks like the problem that I just showed you a while back ago with the multiplication. This number is attached with a variable, which implies multiplication. And I want to leave x by itself, because then there's a number there, and here's another number. They want to be together. So how do you get rid of this number right there? If it implies multiplication, you do the opposite, which is division. Cancels out. 120 divided by 24. So what's 120 divided by 24? Well, equals 5 equals x. Don't think that's bad though, just because the x is on one side. It's the same as saying x equals 5, alright? So these are your solutions. X is 5. So when the x is at the bottom, you guys, yeah, sure, it's an extra step because all you're really doing is converting it into a multiplication problem now. But it's just an extra step. You guys should master it anyways. Just like that. Equations. It's pretty simple, right? This is how you solve it mathematically. Instead of going through your head and going, oh, a number divided by 2 equals 17. What is it? I'm going to start off at 50, then go down to 40, then go to whatever, hoping that you land on the number that will equal 17. Instead of doing all these slowpoke methods, you solve these problems mathematically by using the opposite of its operation. All right? That was division. This was multiplication. This was a negative, and this was a positive. This is how you solve these things, you guys, and you need to master it. These are the basics of it.